What if everything we think we know about the universe is wrong? Look up at the night sky. It feels calm, unchanging, almost eternal. The stars appear fixed, like they've always been there and always will be. For thousands of years, humans believed exactly that the universe was static, stable, permanent, but hidden behind that peaceful sky was a truth so powerful it would completely change our understanding of reality. Forever, in the early 1900s, science was evolving rapidly. We were beginning to understand the laws that govern motion, energy, and gravity. At the center of this revolution was one man, Albert Einstein. Einstein didn't just improve our understanding of gravity, he completely redefined it. Before Einstein, gravity was thought of as a force, something invisible pulling objects together. But Einstein saw it differently. He realized that space itself is not empty. It behaves more like a fabric, and massive objects, like stars and planets, bend that fabric. Imagine placing a heavy ball on a stretched sheet. The sheet curves downward. Now, if you roll a smaller ball nearby, it moves toward the heavier one, not because it's being pulled, but because it's following the curve. That's gravity, not a force, but the shape of space itself. It was a revolutionary idea, and it worked beautifully. But when Einstein applied his equations to the entire universe, something didn't make sense. His equations revealed something unexpected. The universe should not be stable. It should either be collapsing inward, under its own gravity, or expanding outward, in all directions. There was no middle ground, no balance, no eternal stillness. But this contradicted everything scientists believed at the time. Because when they looked at the sky, it didn't seem to be changing. So Einstein faced a dilemma: trust the equations, or trust observation, and he made a choice. Einstein introduced something new into his equations, a term that had never been observed, a kind of invisible energy. He called it the cosmological constant. This mysterious force would push outward, just enough to cancel the pull of gravity, creating a perfectly balanced universe, one that neither expanded nor collapsed, and just like that, the universe was stable again, at least on paper, but reality was about to tell a very different story. While Einstein was refining equations, another scientist was doing something much simpler. He was observing. His name was Edwin Hubble. Hubble used one of the most powerful telescopes of his time to study faint objects in the night sky. These objects appeared as blurry patches. Many believed they were clouds of gas inside our own galaxy. But Hubble wasn't convinced, so he looked closer. And what he discovered was astonishing. These weren't clouds at all. They were galaxies, entire galaxies, each one containing billions of stars, each one far beyond our own Milky Way. Suddenly, the universe became much bigger than anyone had imagined. But that was only the beginning. When Hubble studied the light from these galaxies, he noticed something strange. The light wasn't quite right. It was shifted, stretched toward the red end of the spectrum. This effect is known as redshift, and it happens when something is moving away from you. The faster it moves, the more its light stretches. At first, this might seem like a small detail, but as Hubble collected more data, a pattern began to emerge. Every distant galaxy was moving away, and not randomly, not slowly, but in a very specific way. The farther away a galaxy was, the faster it was moving away. Think about that for a moment. This wasn't just motion. It was a rule, a universal pattern. Everything was moving away from everything else. Not because galaxies were flying through space, but because space itself was expanding. Imagine drawing dots on a balloon. As the balloon inflates, every dot moves away from every other dot. That's exactly what's happening in our universe. The universe isn't just filled with galaxies, it's growing. This discovery led to a profound realization. If the universe is expanding today, then in the past, it must have been smaller. And if you go back far enough, everything must have been closer together, closer and closer, until everything, all matter, all energy, all space, was compressed into a single point, a moment where everything began. This idea became known as the Big Bang, not an explosion in space, but the expansion of space itself, the beginning of time, the beginning of everything we know. When Einstein learned about Hubble's discovery, he immediately understood its significance. The universe was expanding, which meant his cosmological constant was unnecessary. He had added it to force the universe to remain still, but the universe was never still. Einstein later called it his greatest mistake. Even the greatest minds can be wrong. For a while, scientists believed they understood the universe again. Yes, it was expanding, but gravity should slow that expansion over time. Eventually, it might stop, or even reverse. But when scientists looked deeper into space, they found something shocking. The expansion wasn't slowing down, it was speeding up. Something unknown, something invisible, was pushing the universe apart, faster and faster. They called it dark energy. And to this day, we still don't know what it is. It makes up most of the universe, yet we can't see it. We can't touch it. We only know it exists. Because of what it does, this discovery changed everything once again. The universe isn't just expanding, it's accelerating, which means that in the distant future, galaxies will drift so far apart that they will disappear from view. The night sky will grow darker, until one day, future civilizations may look up and see nothing at all. No galaxies, no evidence of the Big Bang, just darkness. And yet, here we are, at a moment in time where we can still see the universe, still study it, still question it. But the most important lesson we've learned is this: the universe is under no obligation to make sense to us, and everything we believe today could still be incomplete, because the sky above us didn't just change once, it's still changing right now.